Utilizing AI tools for water resource management in urban and rural cities. Water scarcity and mistreatment have continued to grow due to the current climate crisis and overuse by humans. World Bank Organization states, water scarcity affects more than 40% of the global population. With urban populations growing to 60% of the world population, water resources in urban areas will become in higher demand and lower supply. Oregon is no stranger to this issue. 40% of Oregon is in severe drought and has been for the last 20 years. This mega drought has created a strain on Oregon's use for cities, agriculture, and tribal communities. Oregon's main problems with water in urban areas, according to the Advisory Council, are water scarcity due to drought and water contamination due to agricultural practices in Central Oregon. Oregon also struggles with creating the resources to properly address water resource management plans to address conservation, quality, and allotment. There are also several issues in creating a water resource management plan. Water is detrimental to every person in a city, but every person also utilizes and treats water differently. WRM requires substantial data and evidence on water use, weather patterns, and water availability. They must also address how to protect water from contaminants seen in urban and agricultural areas. Creating a comprehensive WRM is no easy task. Artificial intelligence programs are becoming a useful tool to address many urban-related issues and will be a useful tool in conserving water and aiding in the transition of an urban city into a green city. Here are some recommendations based on using AI software to create a water resource management plan. Establish a centralized AI-driven water management platform. Create a centralized AI-driven platform with data and map points to monitor and manage water resources in urban areas. Implement AI-enhanced water quality testing. Utilize AI-powered water quality testing using Internet of Things, IoT, sensors at critical points. Utilize big data analytics to create reports based on unstructured and structured data based on collected data from historical evidence, sensors, and patterns. Leverage machine learning for pattern recognition. Create machine learning applications to recognize patterns in water quality over time. Develop AI-driven water allocation plans. Employ machine learning to create accurate water allocation plans based on past water usage, availability, and weather patterns, ensuring efficient distribution of water resources for agriculture, citizens, and city use. Engage AI for community reporting and mapping. Use AI applications to engage citizens in reporting and mapping water contamination and scarcity, facilitating proactive and localized responses to water-related issues. Extend monitoring to rural areas with IoT. Expand water monitoring beyond urban areas by implementing IoT monitors in rural and agricultural regions. Data-driven policy. Implement AI tools to analyze socioeconomic data, aiding policymakers in crafting effective water conservation regulations. Community water footprint apps. Develop applications using AI to calculate and visualize individual and community water usage, fostering awareness and behavioral change. AI technology will continue to advance, as will water scarcity due to the climate crisis. To become a green city that addresses the safety and needs of its citizens, a comprehensive and applicable water resource management plan that addresses water use, the climate crisis, and needs is a requirement.